The homework this week involves several functions over linked lists. You're going to find the homework in the file mylinked0, and that is located in the package algs13. In this video, I just want to walk through and make sure you understand what each function is meant to do. The first of these is going to check the size of a list. So if I have a list with 2 elements, the size would be 2. If I have a list with 4 elements, the size would be 4, etc. And you can see here in the corner case where the list is empty, the size is 0. We'll also have a function here to test the sum of the positive elements. So this is going to compute the sum of the elements but ignore the negative ones. So if I have -3, -4, -1, I just ignore those. I'm going to add instead 11, 21, 31, and 41, resulting in 104. Okay, and you can see so here for some corner cases, if there's only one element and it's negative, well then the sum is 0. That's the same as the empty list. And if I have a single element, well I just return that as my value. The next function you're going to do is a mutator. So it's changing the contents of the list. All of the other functions in this exercise are accessors. They're accessing the list without changing it. So this function will remove the first element. And so you can see the way the test is written, I have the initial value of the list, that's 11, 21, 31. And then the result after the function is called should just remove the first element. So we have 21, 31. And you can see here for some corner cases, if I have a singleton list, I will of course end up with the empty list when I delete it. And if I start with the empty list, there's some choices here of what list 1. The choice I'm going to have you take is just to ignore the function. So the function, the first one is this. So if you try to delete the first element of the empty list, we'll just do nothing. And then what you're being asked to do here is to determine how many. The next two functions values they have in common starting at the beginning. So the first of these is going to check them determine the length of a common prefix. We have 11 and 11, so that's good. 21 and 21, that's good. 31 and 31, that's good. Then we have 41 and 5. Oops, not the same. Okay, so the number of common things here is 3. That's the length of the common prefix. And the test here will show you what happens in various cases. So for example, if I have 11.5 and then 11.21, well, the length of the common prefix is 1. For the empty list, the length of the common prefix will always be 0, regardless of whether it's this or that is an empty list. The final function is just going to look at the even indices of the list. That's the even elements. And we're going to look to see if those elements are strictly increasing. So if I see 11, something I don't care about, then 21, something I don't care about, 31, that's increasing, strictly increasing. If I see a 5 in that position instead, that's not strictly increasing. And so I'll return false for the result of this function. And I do mean strictly increasing. So if I have a repeated value, then that's not strictly increasing. And will return false. And again, in the corner cases here, the singleton and the empty list will always be considered increasing. Okay, so we'll just say true in those cases. So that's the homework problems you're set to do. They're all set in terms of a linked list. These are member functions of the list. So you're working on this list. So my size function here, note it takes no parameters. And that means that you're going to look at this first and then compute the size from there. And likewise for the rest of them. So the only one with a parameter is this length of common prefix, which I discussed before. And as usual, there's some reading up here for you to do. So take a look at the reading and good luck with the homework.